Hey everyone, in this video we're going to talk about the fates of pyruvate, or the potential fates of pyruvate. Recall that pyruvate is the main product of glycolysis. We took the 6-carbon molecule of glucose, basically broke it in half, and ultimately converted it into 2 molecules of pyruvate. Along the way of glycolysis, we made a little bit of ATP, so plus 2 ATP. However, in order to extract the energy or more energy from pyruvate, there are several possible things that could happen. And ultimately, the fates of pyruvate are going to be dictated by presence or absence of oxygen. I'll just say plus minus O2. All right, so let's take a look, and this is just going to be a general scheme here, and then I'm going to break each separate one down a little further. So when O2 is present, so we'll call that O2 plus, what happens to pyruvate is that it will be converted to acetyl-CoA plus CO2. And this molecule, acetyl-CoA, let me just write the name here. That molecule ultimately is going to then enter into the Krebs cycle or citric acid cycle in the mitochondria, and ultimately can go on to make lots and lots of ATP. But that only happens when oxygen is present. All right? Now, in the absence of oxygen, what happens? Well, we'll talk about 2 possible fates here. When O2 is minus in eukaryotes, okay, and by eukaryotes, I'm talking about mammals and all other higher organisms. When oxygen is not present, pyruvate is going to be converted into lactate. Okay, so there's the structure of lactate. And this little pathway, as we'll see, this actually allows organisms like humans to continue to produce a little bit of ATP even when oxygen is not present. It allows us to convert that pyruvate into lactate. Ultimately, if oxygen is not present for a really long time, the amount of lactate builds up and pretty much all metabolism will start to slow significantly down. Now, in certain other organisms, particularly in yeast and certain bacteria, so when O2 is minus, and we'll just say in yeast, there is a different pathway that can occur where ultimately, through a series of several steps, pyruvate is going to get converted into this molecule, which some of you might be familiar with. This is ethanol. All right, so both of these pathways that are in the absence of oxygen, these are called fermentation processes. So this lactic acid fermentation, this is what can happen in eukaryotic cells. And then anaerobic yeast fermentation, this is what ultimately can produce ethanol and obviously alcoholic beverages that we can all hopefully enjoy. Moderately, of course, though. All right, so that gives us a general scheme of the possible fates. What I want to then do is sort of break down each separate one in subsequent videos.